Assalamu alaikum. Now I will be explaining the same diagram for the instant centers technique for the crank dash slider mechanism for this left circuit. For the right circuit I have already explained, but now I will be explaining the instant center technique for the left circuit. So the same line graphs will be used. So here I can label the instant center for this left circuit. So instant center I12 is same because the crank is same, and instant center 2 3 permanent center 2 3 is also same because these are permanent instant centers, and the permanent instant center 3 4 which was here for the right circuit, for the right slider. So I can just, for example, copy just from here and paste it here and move it here and change it to I3 or I can just put the dash symbol because in the second circuit the author has used the dash symbol for the links. So as the connecting rod is different, so I can use it 3 dash, I3 dash and 4 dash, for example, just to make it distinguished from this right slider position. So I have used this dash symbol for this slider. So this is I3 dash 4 dash so now again in a similar manner, as we can observe here, that the effective slider for this circuit as well will be on the infinity will be of infinite length, and its grounded revolute for the rocker will be at infinity as previously that was stated or explained for the this right hand circuit. So I can just, for example, copy and paste it here and just move it here like this, and to distinguish it some different color I can use from here. For example, I can use it some, for example, say green color for this, sorry, for this I can use go into the shape area, and in the shape outline I can use it green color, for example, just to distinguish it. So this is actually the effective rocker at infinite length, and again I can just copy and paste it here, and in a similar manner I can label it. This is link number 1 and this is link number, because link number 1 is common, and this is 4 dash. So in this way. So now as we can observe, the same linear graphs will be used, and we can just assume the dash symbol where necessary. So if we use this instant center for the determination of the unknown instant center I1, 3 for the link number 1 and for the link number 3, so that instant center will be located on the instant center I1, 2 and I2, 3 line. So as we can observe here, this is I1, 2 and this is I2, 3. So that means the same line will be extended here like this. Just extend it, just extend it as possible, as far as possible. So here this is as we can observe, this instant center I1, 2 this is, and the other is 2, 3. So just place it in proper orientation here, exactly on this link. So as we can observe it here. So in this way this instant center has been located, and sorry, so this is the instant center. I can just copy this label from here. So for the case of this left hand circuit, the instant center will be, this instant center will be I1, 3 dash. So because the connecting rod at this position is shown by the dash symbol, so this is the instant center I1, 3 dash. So as we can observe the difference, that for the right circuit the instant center was here, so this line has been a bit changed, while determining this instant center. So for the right circuit, sorry, for the left circuit, the instant center is below here. So this is the difference. So this fifth instant center has been located for this left circuit. So now the sixth instant center can also be located. So use this linear graph. So in a similar manner, use this lower triangle for example. So the instant center 2, 4 will be located on the line connecting the instant center 2, 3 and instant center 3, 4 according to the Kennedy's theorem. So let us see this is instant center 2, 3 and so just use an independent line here to overlap this connecting rod link which actually connect the instant centers 2, 3 and 3, 4 and again go to shape format and change its color to green color just to distinguish it and make it in a dash pattern and make it a bit bold. Once again change the color to green color and its dashed pattern here like this. So as we can observe here there may be slight variation. Place it exactly overlapping on the link as much as possible. So its length is arbitrary. So so now as we can observe that the fifth instant center the sixth instant center 2, 4 will be located on the line connecting 2 and 3 and 3 and 4. So this is 2 and 3 and 3 and 4 are 3 dash and 4 dash in this case. So use the other trio and here we can observe that the exact location of this instant center will be, because the same instant center will be located also on the extended line which actually connects the instant center I1, 2 and 1, 4. So this is as we can observe, this is 1, 4 dash and this is 1, 2 and in a similar manner as we have already observed that in this case it is very technical that as we can observe here the permanent instant center for this slider is at infinity and at point I1, 4 dash. So in a similar manner we will be drawing the parallel line through O2 which is instant center I1, 2 and previously for the right circuit instant center were here, but now as we can observe the line connecting the instant center 2 comma 3 and 3 dash 4 dash or 3 comma 4 in this case, that is actually intersecting here at this location. So that means the instant center will be on the intersection of this vertical line, which is actually connecting the instant center I1 comma 2 and I1 comma 4 dash at infinity. So that means this will be this point. Remember, this point will be the instant center I2 comma 4 dash. So I can just copy this label and just for example paste and just can move it from here. So this is the instant center 2 comma 4 dash. So just for example use this symbol to make it further clear or highlight, and we can also change its color as well. Here like this. So this is the instant center I2 comma 4. So it is very technical that in this case that was located not on any link, but in this case for the left circuit this is located on the connecting rod, because this parallel line is actually intersecting this line which actually connects the instant center 2 comma 3 and 3 comma 4 dash straw at this point. So this is the connection. So the moving instant center or in unknown instant center can be anywhere, that can be on the links or can be off the links or at any point in this plane. So in this way all 6 instant center have been located. This is instant center number 1 permanent, this is instant center 2 comma 3 second, and this instant center 3 dash 4 dash third, and this I1 comma 4 dash the fourth in permanent instant center, and the fifth one was I1 comma 3 here, and the sixth one is here I2 comma 4 dash. So just make this line a bit shorter so that the diagram you are not confused in the diagram. So here like this, just make them a bit shorter so that So here like this is the instance instance centers have been found out. So now we can just graphically measure the angles if we want. So in a similar manner we will be just in a similar manner we will be just solving parallel. So I can just copy the same text here and I can copy it onto the next page. For the left circuit I can just say and just paste it here, and now I will be modifying it. This scale has been mistakenly copied, so it doesn't make any difference. So now I can just change these labels. So this is the AI1 3 dash and B dash. So we will be solving this triangle. For this case, this triangle AI1 comma 1 3 dash, and this is the B dash position, because this is the second position of the slider and here it is written B, so that means this is the B dash position. So in this way, so graphically what I can do, that we can graphically measure these lengths. So graphically now we can calculate these values. For example, AI13 I can directly measure with the help of this scale. So bring this scale onto the diagram. Here, and this is so actually practically while working on the A4 size page, we will be placing the linear scale like this parallel to the line, and here for example from here I can start measuring. So I can observe here that this is equal to somewhat 14 here, 14.1 or 14.2 for example. So in this way I can mention here that according to scale it is 14.2 centimeter, and as per the scale which is equal to 14.7 millimeter, so that is equal to 14.2 multiplied by 14.7, so this is approximately 208.74. so these are just the graphical result, just to 2.874 in this way. So in a similar manner, BI13, that can also be mentioned here. Just input the dash symbol here again, and this is B dash I13. so just measure it here. So as we can observe here, that is equal to approximately, here is 8.1, 8.2 for example, 8.2 centimeter. so as we can observe, that is equal to 8.2 centimeter. so multiply it by 8.2, multiply it by 14.7, so this comes out to be 120.54. so 120.54, 20.54 millimeter. so in this way, so again the VA is same because the input crank is common. so now calculate the omega 3, so or we can say omega 3 dash, so that will be equal to just sorry onto the note here, the symbols were to we were to change the symbols here, so that was equal to 8.2 centimeter, so that came out to be equal to 120.54. so here that came equal to omega 3 dash, so here as well, so here we changed the value to be, this is equal to 208. so here I can just copy paste from here and just paste it here, and so as we can observe here, it is 5.748. so approximate our velocity has been calculated. so I can just copy it here, 5.74 for example, 5.74 radian. Magnitude is almost same, but we notice an important factor here, that in this case as we can observe here, bring this protector now out. so as we can observe here, that the velocity of this point A, as we can observe this link A B dash is in pure rotation about this. So as we can observe here that this velocity V A is perpendicular on this radius and it is trying to rotate it in this direction. So this direction is actually clockwise. So in the clockwise orientation it is moving. So that means I can, for example, just insert here some suitable arrow from here and I can show here that here this is actually the velocity orientation of the connecting rod. So the direction of rotation is clockwise. So that means the angular velocity in this case is negative. So connecting rod is moving in the clockwise orientation in this case. So it has been proved. So here as it can be seen that here the velocity and now B can be calculated for this case. So BI 13 dash that has been calculated here, just copy it from here and paste it here, and now just calculate this angular velocity from here and paste it here. So as now we can just multiply it and just copy and paste it from here. So this comes out to be equal to 691.89 millimeter. So the answer is 691.89 691.899 millimeter per second. So this is the velocity V B dash for this left hand slider. So that can also be observed if we want to plot the direction of the motion of the slider. So that can be seen here that as the angular velocity of the connecting rod is in the counterclockwise orientation. So that means at this stage, because this velocity at a point is now has been shifted temporarily to the connecting rod. So at the connecting rod, this point, this velocity is perpendicular on this link. So it is moving the connecting rod, the extended connecting rod, or this complete body in the clockwise orientation. So that means the rotation of this whole body is actually about this instant center I1, 3 dash. So that means the velocity here will be equal to, I can mention here that the velocity at this point will be in this direction, because this will also be rotating this whole link or AB connecting rod in this or clockwise orientation. So just for example show it here like this. So this will be the velocity VB or the slider velocity. So this is d dot and the velocity of the slider. So in a similar manner, uh, we can apply the law of sines, or the angles can also be calculated. So I will be trying to fastly calculate the angles. So here, as we can observe here, that for example, just create this reference, extend this reference. So as we can observe here, that this angle is 60 degree of the crank with the horizontal. So that means the angle between this horizontal and this crank will be alternate angle, that will also be total angle from here to here will be 60 degree. So as we can observe, this angle is 27.09. so that means this angle from between this connecting rod and this horizontal reference will be equal to 2709. So this angle at point A, this angle will be 60 minus 27.09. so that angle can be mentioned here. For example, just use the arc symbol here and just rotate it here like this. So that means actually these angles can be measured with the help of protractor. So that method has been explained many times. So I hope you will not be finding any problem to measure these angles with the help of protractors. But I am explaining here the angles using trigonometric technique. Again, this angle is 60 degree. So this alternate complete angle up to this crank, and this will be 60 degree. And here this angle is 27.09 degree of the connecting with the horizontal. So this alternate angle will also be 27.09. so that means this angle will be 60 minus 27.09. so that can be shown here, that 60 minus 27.09. so this comes out to be 32.91. so for example, I can just copy any label from here, just for example, and just paste it here. And now I can move it here, and I can just mention it here, the angle, because place is insufficient here. So that means this angle is actually 32.91. so 32.91. so just mention that this angle here is 32.91. so again, this angle is quite simple here, because this angle is 90 degrees. So this angle is 27.09. so that is quite easier. So 90 plus 27.09. so the angle at B dash position can very easily be calculated or mentioned here. Again, use this arc symbol here, for example. So this angle can be mentioned here. Just copy this label and just paste it. Sorry, yeah, just paste it here, that this angle, this complete angle between this connecting rod and this vertical, this angle is 117.09. just copy and paste it from here. So this third angle at I 1, 3 dash can simply be calculated by minusing the sum of this angle and this angle 32.91 from 180 degrees, because the sum of the angles of a triangle is 180 degrees. So we can sum up 117.09 and 32.91 plus 32.91, and this will be equal to 150 degrees. So again, as we can observe here, this third angle will be equal to 30 degrees again, like this. So just for example, I can just copy this label from here, and just for example I can say I can paste it here. So so in this way angles have been mentioned. So these angles can also be measured with the help of protractors, and that is quite simple. So again, if you want, you can copy this arc symbol as well, just here, and just move it, rotate it, and now paste it here like this approximately, just to show the angle representation. So angles have been calculated trigonometrically, and you can also measure the angles with the help of protractor. So that is quite simple. So now angles have been have been calculated, and here now we calculate its equivalent trigonometric results. So use the law of sines in a similar manner. So here, as we can observe, the angle AI1 3 dash, that will be, so here in the diagram we can show that the angle between this side AI1 3, so angle in front of this is angle 117.09. so mention the angle here, angle 117.09. so in a similar manner BI1 3 dash, so this angle will be equal to, as I can show from the diagram, so this angle, this is B dash I1 3, and in front of this is 32.91. so mention it here, this is equal to 32.91 in this way. So the angle between AB in front of AB, as we can observe here, the same angle is sin 30, so that doesn't need to be changed. So now calculate AI1 3 dash and omega 3 dash in a similar manner. Again calculate BI1 3 dash and similar manner. So now calculate the analytic result. So AI1 3 dash will be equal to AB multiplied by sine of 117.09 divided by sine 30. So just type here 120 multiplied by 117.09 and sine of this angle, so and divide it by sine 30, which is equal to 0.5, which is equal to 0.5. so as we can observe here, this is 213.67. so as we can observe here, analytically the result is same. That means the distance or radius AI1 3 dash is same as that was for the right hand circuit. So here is not any change. So now calculate omega 3 dash. So as it can be observed that will be equal to 1200 divided by 213.67. so the angular velocity will be same. So but its direction is very important. So this direction is, as we have observed, that the direction is actually clockwise. So the direction is actually clockwise. In this case, magnitudes for the connecting rods for both the cases are same, but the directions of the angular velocities for the connecting rods are different. In this case, that was actually positive or anti-clockwise, but here in this case it is clockwise for this circuit. So it is important, means the magnitude of angular velocities are same, but the directions are opposite. So now calculate the remaining part, omega 3 SM. So now calculate BI 3 dash. So analytically, so that will be equal to BI1 3 dash will be equal to AB multiplied by sine of 32.91 divided by sine 30. So that can be well calculated here. Again, that 120 multiplied by 32.91 and its sine, and divide it by sine 30, which is equal to 0.5, and this comes out to be equal to 130.397 for example. So just copy and paste it here. So as we can observe here, this is equal to 130.397. so now just paste it here as well, and now we multiply it with the angular velocity omega 3 dash. So just copy it here and again just paste it here, and now as we can observe, the value is 732.3095 millimeters per second. So here just paste the value. So this is the velocity for the slider in the left orientation VB dash, which is equal to the velocity of the slider in the left circuit here. So graphically and trigonometric values have been calculated. So thank you for listening and tolerating, and I hope it will help and assist you in solving graphically and trigonometrically as well. So remember me in your prayers. Jazakallah and Assalamu alaikum.